All right. Hello, everyone. Welcome to Deep Dive. I just realized I had not turned my lights on yet, so let me turn my lights on. There we go. Now you can see me. I'm not in the dark. Hello, everyone. I think you can hear me. Somebody tell me that is so in the chats. Let me pause my previews since we're going. And I'll get started. So hello, everyone. My name is Scott. I work on CircuitPython for Adafruit. If you don't know what those things are, let me tell you. So Adafruit is an open source hardware and software company based out of New York City. I work remotely for them, so I live and work here in Seattle. I've got my Seattle shirt on. Welcome to CircuitPython Day. So if you don't know what CircuitPython Day or CircuitPython is a version of Python designed for little tiny computers called microcontrollers. And I don't actually happen to have one from, oh no, this is an Adafruit one. Here we go. Here's an example. I like to show an example. So here we have, this is an antirez 52840 feather from Adafruit. Adafruit makes a lot of different boards in this same shape so that you can kind of mix and match them. And under this little metal thing here is a little tiny computer called a microcontroller. And it runs CircuitPython, which is a version of Python, all self-contained on these little things. And the way it works when there's USB is it shows up as a drive called CircuitPy. There's a Python source file called code.py, and it edits it there. You can edit it there and it will run right away. It detects when you write the file or when you write to the file system, and it automatically restarts your code. It's super quick to get going. Today is CircuitPython Day. Every year we pick a day to celebrate CircuitPython. The folks who work in the office actually get it as a day off if they want to take it, which is cool. And we do have a discount code today. If you notice, I tried to do the little video intro thing for CircuitPython Day. Everybody at Adafruit does a really great job at the video production, so I'm trying to up my game a little bit. You'll notice I got a wireless mic, and I was hoping to make the background noise better. I do have for those of you who are deep dive viewers, I do have my air conditioning on, but hopefully you can't hear it as much. So deep dive is a stream that I've been doing for a while now. It is actually at this regular time slot, so Fridays at 2 p.m. Pacific, 5 p.m. Eastern. I'll do it unless I'm busy, and then I ask Tim, Foamy Guy, fills in for me. This is a chance to show what I've been working on within the core of CircuitPython. CircuitPython, while to most folks is Python, underneath the hood there's a C layer that adapts all of the Python code to the actual hardware layer, and that's done in C. So that's mainly what we cover in Deep Dive. But it also kind of varies. It's not very well structured. John has all his segments and stuff that he pieces out, but I'm just I usually just show off what I'm working on. I'm also happy to answer questions folks have. So if you have any questions that you think I might be able to answer, I'll give my best. You can drop those in the chats. The two ones hello, NetVentive. I'm following. We have the YouTube chat down here, and then up here is the Discord chat. You can go to the URL adafru.it/discord there, and you can check that out. Yeah, that's where we are during the week, and you can find us there. There's a CircuitPython dev channel. You can ask questions there anytime as well. So I said CP Day up in the corner there is the coupon code. So if you want to support me and Adafruit, you can go to adafruit.com and use that CP Day for 15% off. Doesn't cover quite everything, but yeah, check that out. That's still a pretty good deal. If you live abroad and have a local reseller, that's totally great, and you should support them too. So I don't see any questions. Again, if folks have questions, I feel like I'm known for going off in tangents that people send me on. We do have a hard stop today because we've got Foamy Guy's Game Jam coming at 3 Pacific, so at the end of the hour. So I'll try to give a little few minute buffer there for Tim as well. And I'll also say, and Tim will say this, he does deep dives for the stuff that he's working on Tuesday mornings now, in addition to any filling in that he does for me. So that's the deal. Hi, Creepy Chappy. Welcome to the stream. Again, if folks have questions, let me know. I did do a stream earlier about CircuitPython development, so I'm happy to get into that. So what have I been working on? Well, I've been working on the Zephyr port. So Zephyr is this real-time operating system, and we're working to build CircuitPython on top of Zephyr because it does a lot of stuff for us, and it also abstracts away a lot of stuff across vendors. So I'm currently working on BLE, which is Bluetooth Low Energy. And getting that existing API that we have working on top of Zephyr means that for anything that has Bluetooth support in Zephyr, suddenly we have BLE IO support as well. So I've gotten that working. We've talked about in past deep dives GAP and GATT. GAP is connecting and advertising and stuff. GATT is sending data between devices. And now I'm trying to get the BLE workflow enabled. And I'm like quite close. Quite close. I like got it working on show and tell on Wednesday. I showed off that I had it working with the file glider app on my phone. This is a project. BLE workflow is a thing that we did, I think, in CircuitPython 7, so about 3 years ago, where I really have this. I still have this goal of making it really easy to talk to a CircuitPython device over Bluetooth Low Energy from a phone or a tablet, something where you're on the go, and edit your code quickly and easily. I think that 3 years ago, we did a lot of application work. We have File Glider, which is an app for Android and iOS. It talks to the CircuitPython device and actually uses native iPhone or like phone OS primitives to provide the file system back to other apps, which is pretty cool. But like, there are some apps for editing code on the phone, but it's frankly terrible. And then we didn't really have a good way of like looking at the serial output either. So while we did a lot of work for this, and I think the goal was really good, our first pass a few years ago didn't really work quite well. But a lot has happened, especially in the last year, where large language models have become quite good at taking a, hey, make me a CircuitPython code.py that blinks an LED and producing a working Python like code.py. And so one thing I really want to do is get back to BLE workflow and having an LLM assisted mobile app that talks to them. But then again, I'm getting ahead of myself. I got to get BLE workflow working first. So that is what I've been working on. Toddbot says, I predict we're going to get a bunch of new microphone audio algorithms to remove AC noise in a year or two. All right. I was just like kicking myself today after I finally like tried the new mic and it was like still picking up the fan noise. And then I like finally like figured out how to add a filter to OBS, and it's a noise suppression filter. And I'm like, oh my gosh, that's like very easy, and I should have done that before. Weird stuttering and clipping in YouTube. Everything on my end looks okay. And we should be on Twitch and LinkedIn as well. So let me know if there's anything on my end. I don't see any issues. I'm not getting any warnings in YouTube, for example. Okay, so let's go to the desktop. I actually have my little LLM friend. Okay, it's gone now. I've been using, we talked about this last week as well. I'm using the Pi coding agent, and I have CP Day in front of me. And I actually blue and purple. That's the coupon code if you came in late. You can get 15% off. Captain Codon says your audio is dropping out a bit. That could be the audio filter, I guess. If other folks have that issue, let me know. Tell me I shouldn't have gotten the wireless mic. I do have the other mic that I normally use here as well. Okay, so maybe the new mic. It could be. It could be. I do have the old one, but I just got the like DJI Mic 3 to play around with, so hopefully that's not it. I do like the idea of like not having to unclip myself if I need to go get something, which does happen from time to time. Okay, so this is squirreling away. If you're curious about what I'm trying to mostly use open weight models. So right now I'm using GLM 5.2. It's been what I've been working on using all week. I've been using it enough. I've actually have like 3 separate subscriptions. I just got this Klien Pass subscription because they have GLM 5.2 there as well. It's working on an issue where the tests aren't passing. So I was able to do a manual test with File Glider to do all of the BLE workflow stuff. But one thing that we're gaining with Zephyr is that there is a native simulator. And that native simulator also has a version that can do simulated Bluetooth, all within like the scope of my Linux box. And so Taya says Twitch is okay, great. So even though I had the BLE workflow working, I wanted to establish a basic set of tests as well that test the BLE workflow using the BSIM, which is what it's called. And so I've been trying to get that working. Right now it's running down a problem where so the BSIM has 2 different, it can simulate a number of Nordic devices in particular. I had set it up to do the NRF 5340, but I'm also trying to get it to do the NRF 54 LM20, which is like a really, really interesting chip that is kind of our target. So it's currently working on debugging why it's not working. And so it's figuring out why the BSIM tests for the 54 are not working right now with the changes for BLE workflow. One thing that BLE workflow does change from what's checked in domain and what is in this PR is that Bluetooth actually starts earlier. So that the way that BLE workflow works is that you run boot.py, that gives boot.py a chance to like not do it. And then I'm trying to remember if this is right. It does also do a blink. So with Bluetooth BLE workflow, you get slow yellow blinks. If you reset during that phase, you go into safe mode. You get a blue fast blink. And if you reset there, then you enable, you erase your bonding information and you enable the BLE workflow. And then you run boot.py, and then you actually start up BLE workflow if you wanted to, and then you run code.py. It's very similar to the way USB works, where boot.py runs before the USB is enumerated. So that is one major change for these tests. So like tests that are not new are failing. And so it's trying to figure that out. And it's still going. It says it's figuring out where it's hanging. The BSIM stuff is pretty new, so it's possible that that is the issue. But we'll see what it says. I've been doing more of the reviewing stuff. So some of the other stuff I've been doing today is looking at the commit and trying to go through and say like, oh, I don't like how you did this. So for example, it realized that packet buffer had a problem, and it added, by it I mean my Pi LLM agent, packet buffer, or like it added a bunch of logging and I didn't want to do the logging, so it came up with a different way of doing that. I had some like BLE.io adapter changes in here as well that I didn't decided I didn't want. want to do now. I wanted to do them separately. There's some stuff here, like this is argument checking that shouldn't raise not implemented. So basically I'm like doing a pre-review of the changes that seem to work in my testing, but I'm doing some cleanup basically. It also had to add the ability to Zephyr to like whenever something Bluetooth happens, say, hey, like next time you get to it, like run the BLE workflow because something changed. So that's something that happened here as well. This I also do want to change too, I think, the way that the descriptor list stuff works. It used to just always allocate, but now, let me take a step back. So because the BLE workflow runs when the VM is not running, there's some trickiness around like, make sure you don't allocate to the MicroPython VM when it doesn't exist. And so a lot of the changes that happened in this PR are like, make sure that the version where you don't allocate anything or you don't raise an exception, which also allocates, is okay, and that it works. So that's what a lot of what's going on here is like, change the build so it enables it, and then also make sure that it works without the VM. So you can see here, like this malloc is allocating to the MicroPython VM. This port malloc is something that's been introduced in the last year or two. I forget when I did it. But it's an allocation that happens separate from the VM itself. So that's an example of what this this change is doing. I had it make sure that it could abort discoveries well. It had added this thing that said, like, if I have an active connection, don't reset. But BLE is kind of designed for a world where, like, oh yeah, I walked too far away, or like some radio noise happened and I lost connection. And so instead of being like, let's make sure we keep the connection alive, I've taken the approach of like, no, like at any time it can disconnect and we just need to recover from it. Either recover by throwing an exception or recover by like, let's actually reconnect, would be another legitimate way to do it. In the case that I was dealing with, I was the one doing the reconnection. So that's what it's adding defensive stuff about checking things. I have been being some pretty critical of like LLM generated code adding comments that are not, they're relevant to like the PR that it's working on, but like overall just add noise. So that's something to watch out for when if you get into the world of software stuff with LLMs. It's just like they can be very wordy, and they don't, in my opinion, they don't need to be quite so much. And then packet buffer, it's changing the way there was a race condition that I found, so it's changing the way packet buffer sends stuff out. It realized that we hadn't implemented packet buffer is this weird like wrapper around a characteristic where it's bidirectional packet exchanges. And I think I added it, if I remember right, for BLE MIDI or HID, something like that, where we actually need like multiple writes to a characteristic to be buffered. Yeah, BLE's weird. Have we talked about characteristics? Is that interesting for people to listen to, or should I move on? Do we want to talk about the ways of writing a characteristic or reading a characteristic? That would be a fitting in the weeds thing. I know that I'm a little delayed, so I'll just hang out. I need to look at this in more detail. I'm not sure what this like segment lengths thing is. It looks a little weird. Little weird to me. But that's like something around the locking stuff. I saw David typing for a while and never sent anything. My goal today is I want to get it out as a draft PR at least. Thea says, is that just because we want to send more data than the max limit on a characteristic, like purpose-specific channels of a service? Yeah, don't lose myself on a tangent. Okay, I will, or because we might have incoming between outgoing multiple packets. So I think, so the basic idea, let's talk about this, because I don't think I've talked about it, at least recently, on Deep Dive. So this is talking about GATT. So GATT is the, like, how do two devices that are already connected exchange data back and forth? And what happens is that if you have call these two devices, one device has a server. And so this server is a service. It might be a standard service or a non-standard service. And it has characteristics. And those characteristics make up the server. So the basic example is like battery level service. You have a battery level service. There's a characteristic there that says, hey, here's what my battery level is. And so the server says, I'm serving that. And the client says, hey, what's the value? What's the value of battery level? And it just reads it, right? Very straightforward. And then what's an example where you would like the client can also write to a characteristic. That's the basic stuff. But now the question is like, but then it was like, okay, well, what if I have a battery level service, but I don't want to constantly read to know when the battery level is changing? What I can do is I can say, hey, battery level service, why don't you just let me know? Let me know when this value changes. So there's there's two notions of I'm a server. Somebody's told me they are subscribing to a characteristic. And so when the value changes, I send a notification back to them. So without them having to tell me, I can say, hey, this thing changed. Hey, this thing changed. And then there's a slightly even more weird version of that, which is an indication. So there's notification that says, I just told it, right? But there's also indication, which is, hey, this thing's changed, and I'm going to make sure you know it changed. So you have to send me back a thing that says that you know that it changed. So that's kind of like you can read, you can write, and then on the other side, the server can notify and indicate, which is actually sending data back to the client. And the one thing I missed is that there's also, when you're writing, there's two ways to writing. Just like notification and indicating, you can write without a response that says, hey, just write this thing here. I don't actually care if you get it or whatever. So there's read, write no response, notify, indicate. I think that's what it is. And you can see that like right here on the screen. You can see a property. This characteristic can indicate and notify. And then they take those primitives of like, I just have this value. And then they kind of munge it up more. There's like some complexity about reading a value that's more than the BLE fundamental packet size, which is complicated and gets abstracted away. But actually, when you notify, you don't notify, like say you have a 500 byte value, you don't notify the whole thing. You just notify like the first bit. And then if the thing watching it cares about the whole value, it would read it separately. So that's the primitives that the spec lays out. But then there's things like Nordic UART service. So a UART service is like, hey, I'm giving you just a stream of things, and you're giving me a stream of things back. And so this is what we call, we have a characteristic buffer. So what it's doing is that anytime it gets notified, if you're a client, when you get a notification, we buffer all the notifications so we don't lose any data. And then when we write, we just write with no response as fast as we can. And we kind of expect on the other side, it's buffering writes. So characteristic buffer, buffers incoming writes to characteristics we have. And then packet buffer is kind of like a more comprehensive version of that. So it does buffering both directions. So packet buffer will buffer incoming notifications and incoming write without responses. So it'll build an incoming buffer based on those two things, depending on whether you are the client or the server. And then on the outgoing, packet buffer will, you can say, write this, write this, write this, and it will pack things into a single packet and then send it off. And this is important, I think, for MIDI, but I don't quite remember. Packet buffer does, when you're writing out, it has the ability to put a header and then the rest of it. And it's like the header is optional. It just has to be at the start of the actual packet. So welcome to Deep Dive. We're diving deep into characteristics and buffering on top of BLE. And one thing I didn't say is that, okay, if I'm doing outgoing stuff from a packet buffer, there's actually two ways the packet might actually be sent. One is if I am the client, then I will write with no response to the server. If I am the server, I am notifying, which is like the reverse of write no response, notifying back to the client the outgoing stuff. So yeah, what this found was that, like, so packet buffer is used by the BLE workflow. The BLE workflow is composed of two main things. It's composed of a file transfer service, which gives you all of the like list files, move files, delete files, add files primitives. And then there's also a service that is the serial output. And this is identical to what Nordic has created for the Nordic UART service, except we do different unique IDs for the service and the characteristics so that user code can do a Nordic UART service. But it works the same way. So that is something that the LLM found it needed to do as well. And what we're tweaking here. And that's how it relates to BLE workflow. So in the Zephyr build, so the Zephyr build is unique in CircuitPython. We have this build CircuitPython Python file. It is async IO Python. And so these are the changes that said, hey, if BLE IO is enabled, we're going to append these source files. We're going to enable BLE file service and the serial service. And that triggers the BLE workflow stuff. Here's a log change. Here's a perfect example of what I don't like LLMs doing. It's like, I'm setting this warning value, but it's like it put 5 lines of comment just to tell me why. And I don't actually care. I don't care about that. Here's another example. Although I do want that. So MTU is the max transmission unit, if I remember right, which is basically the maximum size of a BLE packet. And that matters for packet buffer in particular, because packet buffer actually can pack multiple writes into a pending packet. And then sends them all at once. How's everybody doing with all this low-level stuff? And then now we have some tests here that I have not looked at in deep detail yet. It is using not Adafruit BLE. Oh, these are packet buffer tests. So they're meant to be lower level. One thing I've been thinking about is making sure that the tests that are added by LLMs are like somewhat human readable, because they're really like, they are the thing that you can validate works the way that you want. So you may have seen that I added the Adafruit CircuitPython BLE file transfer library to the frozen things because I had already added the ability to use them in use frozen libraries in the actual BSIM tests. So here you can see these tests for workflow advertising. They get the library files for Adafruit BLE from the frozen directory, and then they get put into the CircuitPython drive. You can see here that it's adding all of the Adafruit BLE library files to the CircuitPy drive used in the simulator. So that code.py here can actually be simpler. It's using the standard Adafruit BLE stuff. And so this is like an example of me trying to keep the test code readable by using CircuitPython libraries, which I think is important. Like in a world where I'm not typing the code by hand, like tests are a really great way to show what they're supposed to do. I did look at this packet buffer one that looks more complicated, and like that's the way the previous ones had already been done. And here you can see that it's also, this is getting Adafruit BLE and the file transfer files. It's skipping the LM20, which is fine. We'll take a look at that. But now it's also importing helpers from Adafruit BLE file transfer service, including file transfer, including the service itself and the client for the service. So you can see here that the client actually can just list the directories. And this is actually, this library here is how I prototyped the protocol. This is a new protocol. I had looked at the time and not found a good protocol for sending files and managing files over over BLE. So this was my solution to that. And it was really cool because I was able to do all of the like protocol development in CircuitPython and have both sides, like one library that does both sides, and then re-implement it natively without the VM. So yeah. Audio got a bit of noise canceling clippy, still heard it all. Yeah, it might be that like if I turn just right where it's getting like air blown on it. Actually, I could turn it down. Maybe that'll help. Yeah, so let's just check in and see where this ended up. Okay, so let's read this and see what it says. The fix is complete. Actually, let's see if that's true. You can see I ran it once, and now I'm going to run. So I added this. When I added the BSIM support, I made these really basic tests to make sure that they just start up and they work okay. So it looks like those work. The other thing we can do is we can do clean sim. You got to be a little wary of it. You got to make sure that it actually fixed it. And so let's rebuild the binaries just to make sure that it did that as well. But let's take a look here. We'll finish up in about 15 minutes. So if folks have questions, now is the time. I will read what David said, but let's kind of wrap up the BLE workflow stuff first. Fix is complete. Here's a summary of what I found. It failed because code.py never ran. It initializes Bluetooth, which takes an extra second, and it waits 1 second for discovery. I don't remember that. Run boot.py writes to boot out to flash, but the flash area erase on the RAM C flash hangs. And it hangs because radio sync to ticker. This makes flash erase and write go through NRF flash sync exe, which starts a Bluetooth controller tick timer slot and blocks on semaphore take. So the flash operation blocks for a full timeout, far longer than the test timeout. Since boot.py is called before supervisor workflow start and supervisor Bluetooth init, which calls common how BLEIO runs even earlier, the ticker is already initialized when the boot out write happens, triggering the hang. Okay, so what does it think the fix is? So this, yeah, I've kind of like this has come up a little bit. So Toddbot asks, what are you using to run GLM 5.2? Right now, I am using Klien Pass, which is a subscription. Like Klien is one of the AI editor things. There's a Klien Pass subscription that's like $10 a month. I was using LLama Cloud, but I'm like 90% of the way in my weekly thing. I would recommend LLama Cloud if you want to try it. But they had like Pro and Max versions when I signed up, and I was like, oh, I'll just do Max when I run out of stuff, run out of tokens or like subscription. And I got really close this week, and I'm like, but they turned off Max subscriptions for now because they're like at capacity. So instead, I've like found some other subscriptions that also serve GLM 5.2. I also have an Open Code Go subscription, but I hit my monthly max on that. That's another $10. So I think I'm like $40 in subscriptions right now. 20 for LLama Cloud Pro, 10 for Open Code Go, and 10 for Klien Pass. And I just basically, and they all serve GLM 5.2. I have also been using DeepSeek V4 Pro, but when I was looking at LLama Cloud, GLM 5.2 is like a lower usage tier, so I get more use out of 5.2 theoretically. So let's see what it says. We add the flash NRF radio sync none to disable the broken in BSIM radio sync ticker, matching what NRF does. This is the actual fix. It now finishes in 3 seconds. This is already uncommitted and required. So, okay, so it just got rid of this like radio sync, and that should be fine. Let's just do that. If we find issues because there's not this synchronization, we can always re-enable it. Okay, great. So let's go back to here. We've made the sim, and now let's just do a make test, and we'll talk audio while that runs. We'll see. I don't think they'll all pass, but I think I will. I'm gonna push it as a draft PR anyway, because I think it works, and so people can start playing around with it, and I'll finish polishing it on Monday. I got to run to the airport here soon too. Okay, David says, is there a very audio-minded CircuitPython board from Adafruit, or does it need to be created? Hint, an Adabot suggestion. What does it need to have? Audio in, audio out, micro SD card, few buttons to push or rotate, NeoPixel, VO meter, MIDI legacy connector. Can we add something to the Fruit Jam like an add-on board or some other existing board? Toddbot replied, nothing yet from Adafruit. I have various stabs at this concept on Tindy.com and smallrun.net stores. All open source if you want to build your own. MIDI connector is very necessary, but most small devices use TRS now instead of 5-pin. There is a MIDI feather already. Yeah, I'll just say like all the Zephyr work is setting the foundation for more boards. Obviously, SynthIO does some really cool stuff already. It's green so far, which is good. So yeah, I think you'll just see that like we're gonna start doing some more cool stuff, especially as we find new microcontrollers that we can support via Zephyr that do new things. Obviously, we'll do new hardware to go with that sort of thing. All right. Yeah, this like BSIM TX power thing has been throwing me off a little bit. What models are folks using for LLM coding? Let's see, what is something I can do for the last 10 minutes? Anybody have suggestions for what we talk about in the last 10 minutes? Or you know what? I could actually get this done. Okay, what do we need to do? once again, it has a long explanation. And we will, let's get this draft PR out. So I want to do that. Git commit amend. Get my GitHub ready. Daily workflow force with release. Because it's failing the test, it won't build all of the boards, unfortunately. Getting a draft PR out is a good way to do a final review for me as well. I don't need all this boilerplate. And I'm going to do it as a draft just because it's not actually going to be ready. There we go. So there's BLE workflow. Just add 256 gigs to your Linux box and run GLM 5.2 locally. I think that the antirez DS4 people are playing around with it, I think. That's interesting. The last commit was 2 weeks ago. Yeah, it also supports GLM 5.2 and on very high memory machines, DeepSeek v4 Pro. So I actually do have the latest DeepSeek v4 Flash running on the framework that I've got. The Strix Halo one. They tolerate aggressive routed expert quantization. Strong assistance from GPT and Claude. I wonder, it doesn't say GLM 5.2 requirements. Oh, it says right here. DeepSeek Flash v4, Q2. I'm not sure which one I'm running. And then GLM is, I think it's on multiple, it's probably multiple computers. It doesn't say how much RAM you need for it. All right, this is a great question to end with. Smitka says, I'm generally curious about your opinion on Zephyr. Have you run into any oddities? For example, I'm having trouble setting the correct SPI frequency. Have you run any benchmarks? I have not run any benchmarks. I will tell you that right now. It's a little early, I would say. My opinion of Zephyr, so full disclosure, I was actually like on the Zephyr technical steering committee for like a year or two. I went to those meetings. I hadn't done a lot of Zephyr until recently, like this last 6 months or 8 months, 9 months. It's organizationally very corporate. It's got a lot of like corporate memberships. You get a seat on the technical steering committee if you pay money to join the foundation. It's run by the Linux Foundation. It's very Linuxy in its origins and its style. That's how I got a seat. Like Adafruit paid them for a while to be a member. So my impression then and still has been is that it's not great for CircuitPython because the expectation is the audience is actually people making like devices that are like fixed use devices. So then they inherit a lot of stuff from Linux kernel to do that. They inherit kconfig, which is like how you set what you want compiled in. They inherit device tree, which is how you say, this is the CPU I have and the things that are connected to it and what, like, are they enabled or something is all done kind of at build time using kconfig and device tree. I do not like those things. They are not, they seem to have their origins in like embedded Linux was too large. What would we do if we weren't Linux? But like all the people that did it originally were familiar with those tools. So like they're targeting people moving from embedded Linux to Zephyr. So like all of these complexities are okay. I think they understand that they have like a ramp up cost to that. So that's not great. But what is great is that they just have a lot of buy-in from vendors. Like they've kind of like become the de facto modern real-time operating system. But they also like it's much broader than just that. It's all like device driver abstractions. It's got like an IP stack, a network stack. It's got a Bluetooth stack. So like in our world, like in the microcontroller BLE world, like Nordic Semiconductor, who makes the NRF chips, like with the 52, they had their own soft device implementation, but now they're like all Zephyr all the time. And so like Zephyr gets the latest BLE innovations because Nordic is using them. The BSIM that we're using for these Bluetooth tests is because Nordic uses them. Like the software side of Nordic uses them to test chips that don't even exist yet, right? Like they can simulate them that way. So it's really good for CircuitPython in terms of it being where the vendors are, and the vendors are putting their support into this shared API, shared stack system. So that's why it makes so much sense for us to do that with CircuitPython. And I had to get over this hurdle that it's not perfect for CircuitPython, but also think about the fact that like vendor SDKs are not as well. So for the things that we need to do because we're weird and then we're not fixed, we're like, what CircuitPython does is dictated by user code and code.py and things that it imports. Like we are going to have to figure out how to do things like dynamic pin allocations, whereas like Zephyr expects you to say like, I had this board and these are how the pins are connected, but like I find a lot of pride in the fact that like CircuitPython can put, if the hardware is able to do it, you can put an I2C on any pin and you can have as many I2Cs as you want. So that's going to be one of the challenges I face. Getting that working in Zephyr is like something that's coming up in the next month or two. So yeah, that's kind of my opinion, is that like that's where the vendors are. That's where BLE is. There's a lot of cool stuff around networking. So like they have mobile support. I'm tracking a PR to add ultra wideband support. So like, yeah, it's not perfect, but it does do a really good job at abstracting things away. Like when I wrote the flash support, I never had to think about what flash chip it was again. I don't have to think about, the build system is different, like I said, but I don't have to worry about like which compiler I need and with what flags, because now CircuitPython is built kind of within the Zephyr build. So yeah, it has a lot of advantages. So I'm definitely on board with Zephyr. And then Smika also says, I have a Strix Halo and it's horrible. Almost everything for it is experimental. I mean, in my opinion, all this LLM stuff is experimental. Like I saw Klien Pass had a like annual subscription. I'm like, I'm not paying an annual subscription. Like, I don't know what's gonna come up. Like I'm watching for some new like inference providers to come online, and like everything's really changing in that world. So I don't fault them for that at all. And the DS4 stuff is really interesting to run on the Strix Halo stuff. I actually have on my laptop, I just downloaded Qwen 3.827b. So I'm curious to like actually see how well that can work on my laptop as a like, let me just do this thing and then go off somewhere else. Taya says, looking forward to seeing how the dynamic peripherals pin stuff goes. Also, I'm aware you avoid Arduino code most of the days, but have you taken a look at the Arduino core now it is Zephyr and not beta? I glanced a little bit to see how they do the dynamic like pins, and it looks like they just like kind of like bake them all in, which I don't really want to do because it would like be a lot of space. Kind of my plan is, and I don't know if this will work, is to like basically take the the compile time macros and stuff that generate the structures that the drivers use, and basically say, hey, LLM, make a dynamic version of this. And then like add some tests around it to make sure that they always match. And then just like let LLMs maintain that ability. So it'll be interesting. It's definitely like, I set out like with Phil and Moore, I set out some goals of like what I was going to be doing in the next 2 months. And like, I've gotten through a lot of the easy ones, and BLE workflow is one of those easy ones. BLE audio and pin muxing are going to be trickier for sure. Telling an LLM to like, hey, turn this thing on or implement this existing API with this other API that has lots of examples is like a great use case for LLMs. I still think in my CircuitPython 2026 post, I said that it's great for LLMs are great for tedious work. And I still stand by that. It's just like anything that you think is tedious is something you should take a look at having an LLM do. All right, I'm going to get out of here because in 8 minutes, Tim is going to do a game jam, aka Foamy Guy. If you're interested in BLE workflow on Zephyr, here's the draft PR. You should be able to build it and give it a try. I don't think I've broken it in my refactors, but maybe I have. And I'll get that polished up next week when I'm not enjoying CircuitPython Day. I will go here. So thank you all again for joining me for this deep dive, CircuitPython Day Special Edition. If you aren't often here, this is actually the time slot that I usually do deep dives on. I'm happy to have people show up and ask me questions. So if you ever want to ask me about CircuitPython, this is a great way to do it. If you want to support me and Adafruit, you can go to adafruit.com, purchase hardware there. Today, for CircuitPython Day, we have a CP Day code up there that will give you 15% off many things, but not everything. And Relic SE is just pointing out that the Daisy seed is listed on CircuitPython. That's through the ST port that somebody added, but I think that the Daisy seed might be a good candidate for Zephyr, actually. And I did see, like, yeah, I got to look. Zephyr has a podcast, and they had new boards listed at the bottom, and I saw an STM32H7 HDMI board that I think could be a very cool thing to snag in order to do, like, Fruit Jam V2, something like that. All right, thank you all. If you want to join the Discord, you can go to the URL adafru.id/discord and continue chatting there. This is the live broadcast chat channel. We also have a CircuitPython dev channel and a lot of help with channels. So have a great weekend, everybody. I will do a quick window, because I always do the window. I used to do cat cam when I was at home, but now I'm not at home, and I don't have cats in the room with me. And then I'll do the outro, and have a great weekend, everybody.